In 16th century Europe, life has a certainty that later generations can only envy. Everyone knows that the Earth is the center of the universe. But this reassuring vision is beginning to crack. And one of those who does the most to overturn it is a self-styled genius, Galileo Galilei.
Galileo, of course, was this cocky individual who had an attitude.
The sort of person who makes very close friends and who makes lots of enemies.
But he had a very sharp wit, a very sharp mind, and with that he was able to probe some of the deep mysteries of the universe.
This ambitious, overconfident scientist will remake the world, but pay a harsh price. Galileo is born in 1564 in Pisa, Italy. His father, a lute player, is well known for rejecting convention to create a new form of musical harmony. Galileo inherits his father's rebelliousness. At age 25, he becomes a professor of mathematics at the University of Pisa. But he'll grow scornful of his colleagues, who are still teaching the scientific theories of the Greek philosopher Aristotle, almost 2,000 years after his death.
We forget the fact that before Galileo, there really was no science as we know it. According to the Aristotelian philosophy, for example, objects moved and came to rest not because of friction, but because they got tired. And objects fell to the ground not because of gravity, but because they longed to be united with the earth.
To Galileo, such explanations seem absurd. These grand personages who set out to discover the great truth and never quite find it give me a pain, he later writes. They can't find it because they're always looking in the wrong place. Now, Galileo is about to shatter thousands of years of belief. His intuition tells him that objects move, not because of desires, but because of deep mathematical laws. And his unthinkable step is to find them through experiments, something few people have done before. He begins by studying falling bodies. Physicist Stephen Hawking.
Galileo pointed out that simple observations, like dropping weights from a height, show things do not work the way the ancient Greeks said. This must have been seen by many people, but they had put it down to imperfect observations.
For the first time ever, Galileo begins to work out basic laws of motion, such as how speed is determined by time and acceleration.
It was one of the geniuses of Galileo to slow down the acceleration of gravity. He got an inclined plane and had a ball roll down the plane, and then you could see with your own eyes the fact that an object speeded up as it went down. So he introduced the concept of acceleration.
To us, that seems so obvious and logical. That was a major mathematical breakthrough to understand motion in those terms.
For his role as the first experimenter, Albert Einstein will later call him the father of modern physics. Galileo has pioneered the path that Newton and Einstein will follow. The search for mathematical laws that lie behind all motion. But progress is slow. Only at the end of his life will they finally be published. At age 45, Galileo is still a poorly paid mathematician. But ambitiousness and arrogance will soon catapult him to fame and be his undoing. In 1609, Galileo hears rumors of a toy-like spyglass that makes distant objects appear near. Resolving to capitalize on it, he quickly learns to grind lenses. Within a few weeks, he arrives in Venice with a telescope he champions as his own invention. He impresses Venice's navy so much that officials double his salary.
Galileo did not bother to tell them that this was an instrument that was being exhibited and sold in many other places. There was considerable chagrin when they discovered that, in fact, this was not Galileo's unique invention. Well, what can you say? He was obviously being a good businessman there.
To the free-thinking Galileo, the telescope also offers an opportunity to ask questions few others dare. 60 years earlier, the astronomer Copernicus proposed the radical idea that the Earth revolves around the Sun. But Copernicus had little evidence for his theory, and it contradicts passages in the Bible. In the time of the Inquisition, such speculation treads close to heresy. But Galileo is unfazed. He is the first astronomer to train a telescope on the heavens. And he sees the universe as never before.
He was thrilled by the fact that this telescope is opening whole worlds. He draws pictures and diagrams, and he couldn't draw fast enough.
Galileo works feverishly night after night, and he makes a startling find. He discovers 4 moons orbiting Jupiter. Galileo's evidence that not all objects orbit the Earth lends strong support to the theory that the Earth itself could revolve around the Sun. But contradicting the Bible is theological dynamite. For those who cast doubt on his new theories, Galileo has no patience. He's seen the universe in a new way with his own eyes. How can I do this and not be merely wasting my time, he writes, when those peripatetics who must be convinced show themselves incapable of following even the simplest and easiest of arguments?
Galileo used his cutting wit to cut people down, and that didn't necessarily win him a lot of friends.
In 1615, at age 51, Galileo goes to Rome to argue his case. It may be his greatest mistake. The church orders him to cease teaching that the Earth orbits the Sun. But Galileo pushes his luck. 9 years later, he asks to state his case again. This time, a new pope is a personal friend, and Galileo wins permission to write a book. Ever scornful of opponents, Galileo writes a dialogue and places arguments for the two sides in the mouths of characters who are thinly disguised.
When he wrote his books, it was very clear who was the smart one, who was the stand-in for Galileo, while the Aristotelians come out as the fools.
In 1633, Galileo is arrested by the Inquisition. The church accuses him of heresy. But perhaps the real reason that Galileo is brought to trial is that he has gone too far in his efforts to persuade. Galileo has put one of the Pope's favorite arguments into the mouth of a foolish character in his dialogue.
The Pope was told by people around him that Galileo had tried in the book to make the Pope look a fool. And it was his personal decision to prosecute Galileo to the hilt and have him in house arrest for the rest of his life. It was not really a church decision. It was the Pope's personal decision out of solid anger toward a friend.
Galileo expects a simple compromise. Instead, he is threatened with torture. Bowing to the inevitable, he falls to his knees and recants. For his last 8 years, Galileo lives under house arrest, a broken man. He will gain immortal fame for championing the view that the earth moves around the sun. But to the scientists who succeed him, his greatest achievement is different. In his final years, he writes a book that completes the work that he began while young. He shows how it is possible to use mathematics to analyze motion. Ironically, the year Galileo dies, a boy is born 800 miles away who will bring Galileo's ideas to completion. He will also be one of the strangest scientists of all time. Perhaps no scientist has ever worked so hard without regard for food, sleep, or human relations as Isaac Newton.
Isaac Newton was a much darker figure. He was a loner. He was pathologically incapable of small talk.
We would use the term obsession. I would say he's the closest example I can think of someone who was consumed by his work.
He may also be the greatest scientist of all time. When he is born, the physical world is barely understood. Yet by the time he dies, he's worked out the precise laws that describe all motion, from the fall of an apple to the orbits of planets.
There just hasn't been another human being we know of quite like Newton.
In 1642, Isaac Newton is born in a remote English village. His childhood is an unhappy one. His father dies before he's born, and when he is just 3, his mother farms him out to a stern Puritan grandmother.
When his mother remarried and left him with his grandmother, Newton felt betrayed and isolated, and I think he never quite got over that.
He will later write that his childhood sins included threatening to burn his mother and stepfather in their house. Newton does not always do well in school, but he becomes a curiosity in his village for building extraordinary mechanical devices such as windmills. A schoolmaster convinces his mother to send him to university. At Trinity College, Cambridge, most students drink and carouse more than they study. Newton prefers to be isolated and alone.
Here, looking around him, were a lot of people who had not the least interest in books, who came from well-off families. He must have felt terribly out of place. And also, I suspect, knowing the way that students work, he must have been regarded as an oddball.
Newton, a Puritan, is obsessed with sin. He adopts strict emotional and sexual limits and lives a reclusive, monk-like existence.
Newton was so different from Galileo because Newton was one of the most private people that you would ever know about.
He didn't take pains to make friends, and somehow he didn't relate easily to people. He just pulled back from them.
Throughout his entire life, he has no love affairs and few friends. Some scholars speculate that Newton was homosexual. Others, that he simply decides he has no time for anything but work. It is believed he dies a virgin. In school, Newton pours all of his passion into his studies. Like Galileo, he's captivated by mathematics. He learns advanced math on his own. And then he begins to create a new mathematics to analyze motion. He invents calculus. Newton is fascinated by the way the sun rises and sets in an unbroken arc.
Newton's brilliant insight was the fact that when objects move, they can be viewed incrementally, piece by piece, tiny little increments at a time. And when you add up this motion, you get beautiful spirals, you get ellipses, you get circles. And just remember that when Isaac Newton was scribbling down all his notes, he was creating calculus at the rate at which freshmen in college learn it.
Had he told anyone, he would have been recognized as the greatest mathematician in Europe. But Newton keeps his discoveries to himself, preferring to work out the details alone. Several years later, at age 24, Newton is living in his mother's house. Here, he has an inspiration that will revolutionize all of physics. He will unlock the mystery of what makes the planets move.
Isaac Newton viewed the world pictorially, geometrically, and one day while walking down his estate, he saw an apple fall. And then he gazed up and he saw the moon. And then he asked the key question, the question that unlocked the secret of the heavens. If an apple falls, does the moon also fall? And then perhaps one of the greatest flashes of insight, he realized that gravity, which then takes an apple and makes it fall to the earth, is the same force that could grab the moon in the heavens, and make the moon fall around the earth.
While Galileo began the study of how gravity acts on Earth, Newton is the first to recognize that gravity also moves the planets and stars.
This was an absolutely world-shaking change. Newton essentially showed that the laws of the heavens were the same as the laws down here on Earth.
But when he tries to work out the details, the complex mathematics eludes him. He will keep his great breakthrough to himself for almost 20 years. Newton soon becomes a professor of mathematics at Cambridge University. With few teaching responsibilities, he works on math and physics around the clock. His colleagues will soon recognize his brilliance, as well as his prickly and strange nature. In 1672, Newton's invention of a new telescope wins him admission to the Royal Society, England's association of greatest scientists. Flattered, Newton allows them to publish a brilliant paper on optics. But when the great physicist, Robert Hooke, erroneously challenges his theory, Newton flies into a rage and threatens to withdraw from the Royal Society.
His reaction to criticism is almost always to carefully explain why what the other person has just said is out and out foolish.
He was an extraordinarily fragile personality. As one of his biographers had said, his motto is rule or sulk, and he spent a lot of time sulking.
Some historians speculate that Newton's vindictiveness, inordinate sensitivity to criticism, and obsessive work reveal symptoms of a mental illness such as manic depression. We will never know. If he does have a mental illness, it does not slow him down. At the age of 42, Newton is asked to solve a problem that is baffling England's greatest physicists. What mathematics describes the orbit of planets around the sun? Seized by inspiration, Newton shuts his door and begins work on his greatest masterpiece. Like Galileo, he is guided by strong intuition. Now, he sets out to crack the complex mathematics of gravity that he began years earlier. For almost 2 years, he communicates with almost no one. His only form of exercise is pacing.
He would sleep very little, that he would work 18, 20 hours a day, that he would skip meals and simply write.
He had the power to sit in his chair undistracted, focusing, obsessed with one problem for years at a time until it finally cracked.
At last, Newton reemerges with a masterpiece that will change the world. The Principia. A ruthless simplifier, Newton strikes at the fundamentals. He uncovers how mass interacts with force, inertia, and acceleration. But his greatest insight is to define gravity. He is the first to call gravity a force acting at a distance. And through breathtaking mathematical breakthroughs, Newton lays out the precise laws that determine the motion of all objects.
Newton's Principia, published in 1687, was a scientific revolution. In it, Newton gave the first precise description of the laws that govern the motion of bodies, from cannonballs to planets.
When you look at the Principia and the number of mathematical problems solved in it, doing that in an 18-month period, this is not a normal human being in any sense of the word.
Newton has completed Galileo's quest to mathematize motion. But over 200 years later, another arrogant rebel will discover that at very high speeds, Newton's laws fail, and the universe is stranger than anyone ever imagined.